We're going to have general rules, and we're going to have rules for specific atoms. So let's look at first the general rules. For an atom in its elemental form, this includes diatomics. If they're just in their elemental form, there's no charge on them. Sodium would be an example of this. O2, which is a diatomic molecule, that's its elemental form here on planet Earth. Cl2, etc. Any of the elements that are on the periodic table are assigned an oxidation number of 0. So this is our first general rule. If I give you an element on the periodic table and I say mercury, Hg, and assign the oxidation number, you know instantly that it's a 0. There is no charge on that mercury. It's in its elemental form. It is considered a 0. Now if I give you an H2 molecule, we know that H2 is one of our 7 diatomic molecules, diatomic elements, and so it has to be found as H2 in nature. So if H2 comes as H2 in a reaction, it's going to be assigned an oxidation number of 0. So that's our first rule. Second rule, for monoatomic ions, oxidation number equals the ion charge. What in the world is a monoatomic ion? This is any element that has become an ion in an ionic bond, or if it's an ion in its ionic form in a solution. So if the sodium was Na+, that's a monoatomic ion. The oxidation number for Na+ would be +1. The oxidation number for O2-, so the ionic form of oxygen, would be a 2-. So anytime we have an ion, the oxidation number equals the charge on that ion. The sum of the oxidation number values for the atoms in a compound equals 0. So if we have a compound, let's say we have NaCl, we know that the overall oxidation number has to equal 0. Compounds are neutral molecules, neutral compounds. So they cannot have a disparity between the positive oxidation number and the negative oxidation number. So if we're looking at sodium chloride, we know the formula is NaCl. The sodium is in its ionic form. It has an Na+1. And the Cl is in its ionic form, Cl-1. So the oxidation number for sodium ion in that case would be a +1. The oxidation number for chlorine in that case would be a -1. They sum together to give you 0. The sum of the oxidation number values for the atoms in polyatomic ions equals the ion's charge. So whatever the charge is on those polyatomics, our 7 polyatomics, we're going to know exactly what all of the oxidation numbers have to add up to equal. So we'll do a lot of these in class tomorrow. So these are the general rules. Let's look at some very specific rules on the periodic table. Group 1A, the oxidation number is always going to be a +1 compound, or a +1 in all compounds. Sodium, potassium, any of those elements that are in the group 1 are going to take a +1 oxidation number. Very similar to the charge that they take when they're in their ionic form. So that's a rule. This is why I'm having you memorize this. You already know some of these rules. Group 2, the oxidation number is going to equal +2 in all compounds. So this is very similar to what we already know about ions. If magnesium was bonding with oxygen, the magnesium is a 2+, the oxygen is a 2-. Magnesium's oxidation number is going to be a 2+. So very similar to what we already know. For hydrogen in this class is going to be a +1 in combination with nonmetals. And for this class, I don't think we're ever going to come across a case where hydrogen is not a +1. If it is, I will make specific, I will tell you that right off the bat. I will never have you calculate oxygen that's not a +1. Assume that it's a +1 when it's bonded to nonmetals. Fluorine is a -1 in combination with metals and boron. That makes sense. Fluorine's a halogen. It's going to form a -1 when it's bonding to any metal. Oxygen is going to be our rock. We will not come across peroxides in this class. We will only take oxygen in a compound or a molecule as an oxidation number of -2. This is going to be the rock. Assume now that anytime we have a compound or molecule, oxygen is going to have an oxidation number of a -2. Okay? Group 7, these are the halogens. They form an oxidation number of -1 in combination with metals, nonmetals, and other halogens lower in the group. So if we're bonding a covalently bonded system between fluorine and iodine, the fluorine would take the -1 charge, the iodine would take a different charge, an oxidation number, not charge, oxidation number. So these are our general rules. I suggest printing this page out and committing this to memory. We're going to be using these a lot.